I hope you did this problem before you started this video. If you haven't done this problem, push pause and try it on your own. Our goal is to use the derivative to find the critical value and the critical point, or critical values and critical points of the h of x. Here is our function h of x. X to the third minus 6x squared plus 12x minus 4 is our function. We start by taking the derivative of that function. Let's take the derivative, h prime of x is equal to 3x squared minus 12x plus 12 plus 0. Then we set that derivative equal to 0. And then we solve. This is a quadratic equation, so we can solve a number of ways. We can use the quadratic formula if we would like. What I am going to do is I'm going to divide both sides by 3. I think that will be one of the easier methods. If I divide the right-hand side by 3, I get x squared minus 4x plus 12 plus 4. The left-hand side, if I divide that by 3, I just get 0. Now this equation is ready to be factored in order to solve it. You get x minus 2 times x minus 2 is equal to 0. In other words, x minus 2 has to be 0, or x minus 2 has to be 0. I don't have to write the equation twice if I know it's going to produce the same answer. In this situation, we got x equals 2. So I took the derivative, set it equal to 0, solve for x. Therefore, when you plug in 2 into the derivative, you're going to end up with a 0. So h of x has a critical value of 2. Or some people will write this as h of x has a critical value of x equals 2. In order to find the critical point, what I have to do is plug in 2 for my x value, and then plug in the function value when x is 2 for the second portion. We get 2 comma h of 2. When you plug in 2 into the function h, be very careful here. You're not plugging in 2 into your derivative. You're plugging in 2 into your original function. So make sure you don't make that mistake. There's a lot of people who will inevitably make that mistake. Let's plug that in. So replace all the x's with a 2. When that's all calculated, the output value of my original function, when the input value is 2, becomes a 4. So my critical point is the point 2, 4. That's how we find the critical point and critical values of a function like this. You can imagine that there are certain scenarios in which these two x's, these two factors will produce different x values. And then we'd have multiple critical points on the same problem. So we don't always have to have just one critical point or one critical value. We can have multiple critical values.